G'day Super Nerds. In this video we are going to look at the SI units of the metric system and prefixes that we use in the metric system. So that's what we're all about. We're all about metric. Base 10. It's good. And these are the base units we'll use to measure stuff in science. Now remember, in science, stuff is a technical term meaning matter. We're using this to measure matter, distances, blah, blah, whatever. But this is what we use to measure stuff. So our learning goal here is to be able to make conversions and understand the prefixes of the metric system. So when we say conversions, we are talking about factor conversions. So it's like instead of going from like meter to furlong, which is not like a metric unit anyway, we're talking about going from degrees centigrade Celsius to Fahrenheit. We're actually talking about going from the millimeter to the meter. That's the sort of conversions. And by the end of this, if you've been successful, you'll be able to make some conversions. So this is your vocabulary. If I can just get you to pause this, write down this, draw the little diagram, it'll come back in a minute. Pause this, write it, and you'll have something to refer back to as we move throughout the lesson. So SI units. The first one that comes to mind for me is the meter. It's a unit of distance, and the unit is the meter. So that's what we're measuring here. Usually an M is the symbol for it. That's what should be in that bracket right there. The second one is the unit of time, or the second. And that's, we're all fairly well acquainted. So there's nothing too out of the ordinary yet. Then there is Kelvin. Kelvin is our temperature. All right. So we have an absolute 0 of Kelvin, which we don't have with degrees Celsius. And 1 degree Celsius equals 1 Kelvin, so it's a 1-to-1 swap over as far as how large they are, but 25 degrees Celsius is 298.15 Kelvin. That's because there's an absolute 0. There's nowhere 0. So temperature is actually thermal energy. It's the amount of energy that particles have and how they move, and because of that energy, and we measure something called temperature, and the unit is Kelvin. So kilogram, this is an interesting one. I'll show you why. Kilogram is 1,000 grams. Our SI unit, our base unit, is kilogram, even though it has the prefix on the front. It's a unit of mass, not weight. Weight is force due to gravity. So if we put a 1 kilogram on the moon, it should be about, I don't know, like a sixth of that. So if we were to weigh it, it would be on a scale, it would be weighed as 1.666 kilograms. However, the mass, the amount of mass, which is the kilogram itself, would not change. So kilogram is mass, which is the amount of matter, not weight. Weight is a force. Then we have the ampere, which is the unit of electric current. Then we have candela, which is luminous intensity. So how bright a light is measured in candela. And there's actually other units, but candela is the metric system unit. It's the base unit. And then we have moles. This one's most interesting to chemists. We love this. Moles is the amount of substance, not the amount of matter, but the amount of particles in there. For example, you have 1 mole of, it doesn't matter. Mole is amount of particles, and that's quite an interesting one. So the root of the word is molecule, and what it means is of the elementary particles of a substance, 1 mole is the amount, which is the amount of particles, elementary particles, as you find particles of carbon in 0.012 kilograms, 12 grams, of carbon-12, a particular type of atom. So it's a really specific measure. And basically, if we've got 12 grams of carbon, because its atomic mass is 12, however many particles that is, that's a mole. Everything else comes from that. It's a really, really useful and important measurement in chemistry. In fact, in chemistry, we convert everything to moles, because we're talking about individual particles and not mass, because different particles have different mass. So, yeah. Anyway, that's the SI units for chemistry. That's some crazy stuff in the mole. So, prefixes in the metric system. Basically, on this table here, we'll start with tera. Okay, the name is tera. It has a symbol T, which means if we have a teragram, it is a big T, little g. That's a teragram. Now, tera has a base 10 unit of 10 to the power of 12, which means it's 1 with 12 zeros off it. So that's our multiplier. So for something that's a teragram, it is 1 gram times that number. And the word for this is trillion. It's actually not a bigger number. Okay, so then we have giga, which makes a bit of sense if you've spent time around computers, gigahertz or gigabyte, and that's 10 to the 9. So a gigagram would be 10 to the 9 grams. 1 times 10 to the 9 grams, or a billion grams. Then we have mega, back more into useful numbers that we're used to, and we're looking at millions, or 10 to the power of 6, or 1 with 6 zeros off it. So we see how this is going. So a megagram is 1 million grams. Or we have a kilogram. Ignore this little bit down here. That'll come up in a minute. We have a kilogram, which has a K in the front, or kilo, sorry. 10 to the power of 3. Multiply it by 1,000. So if it's 1 kg, there's 1,000 grams, and that's 1,000. Then we have the just straight 1. Okay, we call it ones, unit of ones. Now, what you'll notice is that there are also deca and centa. We have gone up in units by factors of 3, because that tends to be how we don't really work in, say, deciliters or centiliters. We work in milliliters, liters. Or decigrams, centigrams. We work in grams or kilograms, because those hundreds and tens, the math isn't too awkward. It still works. So then we get to deci, okay, which is 10 to the minus 1. Now, when we go the other way, we use be a bit more comprehensive. So that's base 10 to the minus 1. The multiplier is 0.1 grams, or 0.1. So if I have 1 decigram, I have 0.1 gram. If I have 7 decigrams, I have 0.7 grams. Centimeters. Okay, so if I have a centimeter, if I have 1 centimeter, I have 0.01 meter, and it's 100th. Then we have the milli, which is the thousandth. That one's confusing. That confused me all through, like, primary school, maybe high school. Way too long. I found milli confusing. Milli is a thousandth. 0.001 is the multiplier. 10 to the negative 3 is the base. Lower m, so little m meters is millimeters, and it's a thousandth of a meter. Then we get to micro. We go for a bigger skip here, and that's a millionth, and that's 0.000. Lost track. 0.00001 gram for a microgram. Then we get to nano. By the way, note that micro has a weird little symbol. It looks like a U with an extra bit off the side, off the bottom. Then we get to nano, which is 10 to the negative 9, and it's a billionth. Pico, which is a trillionth. It's the opposite of our tera. All right, if you have any questions, put them in the comments below, and we'll get back to you as quick as we can. Thank you for watching. Don't forget to subscribe, and we'll see you next time. Bye now.